Hey everyone, welcome back. In this video, we'll be discussing about the third and the fourth problem of today's weekly contest. Minimum number of valid strings to form target 1 and minimum number of valid strings to form target 2. Both the problems are exactly equal, the only difference lies in the constraint. So as always, we'll start from the very brute force solution and try to optimize it step by step. So let's get started. The problem states that you're given an array of string words and a string target. A string x is called valid if x is prefix of any string in words. So our job is to return the minimum number of valid strings that can be concatenated to form the target. If it is not possible to form the target, you will return -1. So let's take an example. Let's say the words has these three word ABC, AAAA, BCDEF, and we have to form this particular string from valid strings. Now again, what is valid string? Valid string is any prefix of any word in the words array. So you can either take A or AB or ABC or A or AAA, and so on and so forth. So all of these are valid strings. So you can take any of them and try to make target, and your job is to find out in how many minimum string you can make target from these valid strings. So one of the way could be you start with AA. So you make AA to match this one, and then you take BCD, which is again a valid string because it is a prefix of one of the word in the words, and you match BCD here, and then you take ABC, which is again a valid string. So you take you match ABC there. So you concatenated three valid strings to form the given target, and you can try out any other possible combination. You will not be able to make target in less than three valid string concatenation, and hence the answer here is 3. So let's take one more example. Let's say words is ABCDEF and target is XYZ. In that case, no matter what you do, all the valid strings starts from A, AB, ABC, and so on and so forth. So there is no valid string that can give you X as the first character, and hence you can't actually make target from the given words or the given set of valid strings, and hence answer here is -1. So hope the problem statement is clear. Now what's the very brute way to solve this problem? So you are given this string, and these are the set of strings or words that are given to you. Now what is your first step? The first step could be, okay, I will try out one of the valid string from all the valid strings combination of these three words, and let's say I figure out, okay, I will try out this particular valid string AA. So if I try out this particular valid string first, I am left with these all characters. Now what I want how many minimum valid strings are needed to form BCD ABC, given the set of valid strings are still same. Isn't this problem exactly equal to the original problem? Original problem was given some target, tell me how many minimum number of valid strings are required to form this target. Now what you are saying is, given a smaller target, tell me how many minimum number of valid strings are required to form the given target. So hope you can see the recursion here. Whatever function you will use to solve this entire problem, you can apply the same function to solve this problem as well, and you can recursively keep on doing that until you get the answer, right? So in simple words, you will have some f of index which will give you, okay, for any string starting at, let's say, index I, how many valid strings are required to form the target everything after I, right? So if you have this function, you can easily break the problem into a set of these functions itself. Let's if you understand the approach, I would encourage you to pause and try to write a pseudo code by yourself I intentionally left the matching part ambiguous here, but we will deep dive into it while doing a dry run. So next we will be doing a dry run. This is how the function would or the recursion would proceed. Let's say you want to first figure out f of 0, right? Because you want how many valid strings are required to form everything starting at index 0, right? Which is this entire string. So what are the choices? Or rather, what are your possible options at this state? One of the option could be, okay, I will try to match ABC with this. So here A and A is match, which means for sure you can have a valid string of A and match it with A. That's one possible option. And if you follow this option, what you are left with is this entire string to be matched with some other valid strings. So what you will say, okay, I matched A, give me how many minimum number of valid strings are required to form ABCD ABC. So in other words, you will say, I have matched A, tell me the value of f of 1, right? What are other choices? So for the string which starts, well, like for this particular string, there is no further match, right? So this is gone. Let's start with this one. Here again, this is a valid match. So you can again say, okay, for this particular match, give me what is the minimum number of strings required to form the remaining string, which is equivalent to the previous one. So let's skip this part. The second could be, okay, A and A is also a match. So you can say, okay, I will take this one as my first valid string and match it with AA. Now give me what is the minimum number of string required to form the remaining BCD ABC, which is I take one valid string AA and matched 0 and 1 character. Now give me what is the minimum number of strings required to form a target of everything starting at index 2, right? Now in the similar fashion, for f of 1 as well, you will apply the exact same trick. Let's do this one more time. So for f of 1, you will say, starting at this character, tell me how many valid strings are required. That's what f of 1 is. So again, you start matching. You take the first one. This is a valid match. So which in turn means that you can take this string alone and say, okay, I match this one alone as the first valid match. Now give me what is the minimum number of strings required to match BCD ABC, which in turn is simply f of 2, right? You take A as a valid match and you wanted f of 2. Now what else? AB is also a valid match here, which is you can take this particular valid string and match this in here and say, give me the minimum number of string required to match the remaining one, which is saying I match AB here, I match AB here, give me the value of f of 3, which is everything starting at CD ABC. And finally, you can match ABC as well. In that case, you will say, I have matched 3 characters ABC here. Now give me everything, minimum number of strings required to match DABC from the given set of valid strings. Now, what will be the answer of f of 1? Let's say f of 2 gives you x1, f of 3 gives you x2, and f of 4 gives you x3. So the value of f of 1 would simply be the minimum of 1 plus x1, 1 plus x2, 1 plus x3. Why 1 plus? Because this is one match that you have done, or this is one particular valid string that you have included in your set of strings that you will finally use to make everything starting at index 1. So whichever is minimum, you will take that one, and 1 plus that minimum value will be the answer for f of 1. In the same fashion, you will figure out the value of f of 2 as well. Once you get the value of f of 2, let's say this entire thing comes as y1 and this entire thing comes as y2. The value of f of 0 would simply be 1 plus minimum of y1 comma y2. Again, the same reason, you have already chosen one string here, and afterwards you are saying that I need y1 more strings. Here you are saying I need y2 more strings. So overall string required in this path is y1 plus 1. Overall number of strings required in this path will be y2 plus 1. Whichever is minimum, you will just take that one to get your final result of f of 0. So hope this entire thing is clear. Now, if you have watched this point, strongly encourage you to pause and try to write the pseudocode and determine the time complexity of that as well. So next, we're looking at the pseudocode. The pseudocode is exactly what we discussed. We have a function f of index which simply return us what is the minimum number of strings required to form everything starting at index ind. So if the base case is like if you have exhausted the entire string, in other words, you are saying that what is the minimum number of strings required to form everything after index n. So there is nothing after index n. So minimum number of strings required would be 0, right? So that's the base case. This will come to this is simple memorization. You can see here that f of 2 you need multiple times. Similarly, f of 3 is something you need multiple times. So instead of computing f of 2 again and again, and similarly f of 1 again and again, you can store it and reuse it if you need it again. So that's simple memorization technique which we have used here to avoid recomputation of same index twice. Now after that, we figure out what are the valid matches starting at this particular index. We'll come to this, but once you figure out what are the valid matches, I will iterate over each of the matches and figure out how many more strings I need for the remaining set of characters, and I will add 1 to that to get what is the total number of strings required starting at the current index, and I will keep on taking minimum across all such value to get my final result. Right now, how we are figuring out length? Again, simple thing, we start with every string. So here let's say we start with abc. For abc we figure out what is the match. So first, if length 1 is match, if length 1 matches, you are saying that okay, I have a match of length 1. Then you will say okay, is length 2 matches? Answer is no. So you will not add length 2 here, and you will stop as well, because if length 2 doesn't match, none of them afterward will match. Similarly, then you can try with second word in the words array. Length 1 matches, but length 1 is already there, so you can ignore. Length 2 matches, so length 2 you can add this to your length array. Length 3 doesn't matches, and you will not move forward, because if length 3 doesn't matches, nothing else will match as well. So this is, and this ends here. And finally, for the third one as well, you will do the same thing. Is length 1 match? No. So you will end your match directly here. And finally, you have your length array, which basically says there is a valid string which can match 1 character. There is a valid string which can match 2 character. Now I need to choose among these two, so I will just try out both the things and see whichever is giving me the total minimum number of strings, and that will be my answer, right? So what is the overall time complexity of this entire algorithm? It's simply like number of states multiplied by what you are doing inside each of the state, because each state is computed exactly once because of this memorization technique, right? Now how many states are there, or rather let's first figure out for a particular state what you are doing inside each of the state. We are figuring out all the lengths, so there are two major loops, this one and this one. Let's first figure out this one. How many lengths can be there at max in this length array? The answer is total length of the string itself. If this string length is, let's say, 10, you can't have more than 10 different length here, because what that would mean is, let's say you have 11 as well. In that case, what would mean, there is a match which matches 11 characters here, which is not possible because there is no 11 character at all. So the worst case part of this entire for loop would simply be order n. where, or rather let's say order t, where t is the length of the target string, right? Now, what about this loop? This loop, first one running over order w time, right? Second one running over the length of each of the string, right? And inside that we are doing some substring match as well, but this substring match you can easily do one at a time. Instead of figuring out all the substring, you can do this match incrementally as we have discussed. For example, for a, you can start matching with this, and then you can match this one. So for this matching, you don't need to like match this entire thing again. You can simply say if this matches or not. If this matches, then this entire thing would match as well, because everything before is something you have already matched, right? So that's how you can like simply reduce this entire thing. Again, if you don't understand this, just try to think for a moment, and I'm very sure you'll be able to get it. So overall, this is the time complexity of the of calculating a single state inside this function, right? Now, what about the number of states? Number of states is number of different ways to call this function. So number of different values of index could be order t again, where t is the length of this entire string. So this is also t. So overall complexity of the current algorithm is order t cross t plus w cross lw. Now this w cross lw, if you look at it closely, this is nothing but the sum of all the characters of the words array, right? So they just replace this entire thing with sum of all the characters of word array. So this is your overall time complexity. Now, will this pass? Let's start with the third problem first, because that has lesser constraint. For third problem, sum of word of length is 10 power 5. So this is 10 power 5. The length of word is 5 into 10 power 3. So let's make it 5 into 10 power 3. And similarly, this is also 5 into 10 power 3. So obviously 5 into 10 power 3 plus in multiplied 10 power 5, this will not pass, right? So you can afford t into t, but you can't afford t into summation of word length. So you need to reduce this time complexity even to work for the third problem. So how to reduce this summation of w with something else? Strongly encourage you to pause and try to think for a moment. The only thing you have to do is somehow think of a better matching algorithm than this for loop that we are trying to do here. So hope you thought about it. There is very less matching algorithm when it comes to string matching. There's KMP, Z, and finally try. So if you think naively, like you should be able to understand that, okay, even though I'm matching everything here, like sum of w, I am spending this much time. Worst case, I will be iterating over all the characters here, right? Nothing more than that. And number of characters here is only order t. So anything after order t is kind of a waste, because that is something I might have already discovered, right? So just to visualize this better, let's build a try. Again, why try? Because we know that we are iterating over every string and its length for every match, but and this is costing us 10 power 5 iterations. But we know that even though we are doing a 10 power 5 iterations, in no case we will be able to match more than 5 into 10 power 3 characters, because that's the maximum length of t, right? So what we can simply do, if we can reduce this 10 power 5 into 5 into 10 power 3, our job will be done. So we can build a try out of it. And now instead of matching everything one by one, every match can be done parallelly. So let's say you start at this one and you wanted to know how many different lengths you can get. So for this one, you can start at root. You can go to a. I think for a better representation, this should be something like this, right? Just assume that all of these are like this. So in this case, you start with a, you go to the direction of a, you get a node, which means you have a length of 1 with you, which indirectly means that there is at least one string which has a, and that's why you have this a node in the trie. Now once you have done this, you will increment and say, okay, can I match ab? So you can come here and ask for b. B is also there, which in turn means there's at least one string which has ab. That's why you have this node. So you will simply add 2 as well to your length. Now you'll come to C. You'll say, okay, can I get C? Answer is yes. You're getting C, which again means that there is at least one string which has ABC in them. So I can have a match of 1 to 3 as well. Match of length 3 as well. Now you'll move forward to D. You'll say, okay, can I get D from this node? Now the answer is no. You can't get D, which means there is no node there is no string at all which has a prefix of ABCD, and hence you can't get a 4 here. And because you can't get 4, you can't get 5, 6, and others as well. So in other words, you are simply iterating over the trie, and this iteration can continue at max the length of the original string itself, which is the length of the target itself. So what you have done, you have simply replaced this entire for loop or this entire summation of w with a trie match which can run over order t time. So this entire algorithm would be order t square. So in terms of pseudocode, this is how this would be replaced. You will build a trie first. Building a trie would take order summation of w time, right? Once you have built the trie, everything afterward is that function. We'll come to that function again, but this summation of w is not an issue because summation of w is still 10 power 5. So this entire thing you can build very efficiently. Now once you have built efficiently, you can simply replace this for loop with something like this function, and from this you will get, and this entire function will run in order t time, and this entire function already runs in order t time. So for a single state, you need order t time to compute a single state, and total number of states is t. So overall complexity of this entire algorithm is order t square, which will pass plus summation w as well because you are building the trie as well. So this entire thing will pass the given time constraint for problem 3 because the value of t is 10 power 5 into 10 power 3 is here. But this will not work for the last problem because the value of t there was